Hi, this section is going to be posted under classwork. The blank copy will be reposted under classwork. Right now it's in the module, I think. And I want you to turn this in. This will be your homework, but it'll count as classwork points. I'm not going to do all of these. I'm going to just to kind of pick and choose a couple of these to do, just to kind of remind you what the different techniques are. So for number one, what you want to do is you want to solve for cosine of x. So we're going to move the 1 over and then divide by the root 2. So cosine of x is equal to positive 1 over root 2. Okay, this is kind of the simplest one because we just need to figure out where cosine is 1 over root 2. And 1 over root 2, if you rationalize it, it's recognizable as root 2 over 2, which is our coordinate at all the 45-degree angles on the unit circle. So to figure out, to do this kind of problem, you want to look at a unit circle. At least this is my approach. There are other approaches, but just make sure when you're doing these that you get all the answers. Okay, so cosine of x is root 2 over 2 right here at the 45 degrees, or pi over 4 as we prefer. Over here, it's negative root 2 over 2, so we don't pick that one or this one. But you might forget that there is another time that there's you're in positive root 2 over 2 for the x coordinate on the unit circle. And that happens, again, if we're looking at the directions, which you kind of need to for these ones, because we could call that negative pi over 4. But then it wouldn't be in the interval that we're looking for. So we actually want to call this, we're 1/4 short of 2 pi, so that will be 7 pi over 4. So for our solution, we would get pi over 4 and 7 pi over 4. I'm not going to worry about writing all the solutions, but it is something that you should know. All solutions would be written out as x equals, say, pi over 4 plus 2 pi k and 7 pi over 4 plus 2 pi k, with k an integer. Okay. For number 2, that one's really straightforward. Number 3, factor. A lot of these are factoring. So those skills where you can just do a substitution, or I think most of you are probably comfortable just to, like, for number 3, for instance, you can see that it's a difference of squares. So you can do cosecant x minus 2, cosecant x plus 2. And I'm not having much luck with cosecants. Okay. And then you set each factor equal to 0. I'm just going to hit dot, 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 because I think you guys can do that one. And it usually helps if you change cosecant to 1 over sine and then solve for sine of x, and take that unit circle approach to make sure you get all the answers and not just one. Another kind of possibility here, all of the equations that I'll give you will have exact solutions, so you'll be able to do them this way. But you could alternately, when you have this, like cosine of x equals 1 over root 2, you could just use your calculator. Let me see if I have it. And do inverse cosine of 1 over root 2. And you can see it gives you 45 degrees. Now the danger in that are two things. So really the main danger is missing the other solution that might be the relevant of the two, or might not be. You want to make sure that we're not dismissing relevant solutions. So, or that anything that we dismiss is conscious and not accidental. Okay. For number 4, it's already factored. Set each factor equal to 0. Whatever you do, don't divide. By an expression with a variable in it. So I'll say by an unknown. And it's because 0. So when you're dividing both sides of the equation by, say, secant x or anything that could be 0, then you are kind of killing things a little bit. You're losing information, because if x were 0, then you just divided both sides by 0, and you really just lose the information that that's a possible solution. So like in this instance, if we divided both sides by secant x, the times that secant x are 0 that make this equation true are being dismissed. So we don't want to do that. For number 5, you also want to factor. And for number 6, you want to factor. This one's quadratic in form, so you want to factor. And for this one, we have 4, but I think you can do factor by grouping. Okay. I want to talk about this one really quickly when we're talking about the half angle formulas. For this one, I would rewrite secant as 1 over cosine. And then we have cosine squared of x over 2 equal to 1. These are a little different, so I'll do one of these where we're messing with the argument, and the argument isn't just x, then we have a slightly different scenario. I actually probably should either factor this or make sure that when I need to use my plus minus when I take the square root. So I get a plus or minus 1. So I want to know all the places where cosine is positive or negative 1 here, and that will be cosine is 1 here, and cosine is negative 1 here, and that's it. So it's the argument that is either 0 or pi. So x over 2 is either 0 or x over 2 is equal to pi. And so then x equals 0, x equals 2 pi. And those are really the same thing. So the solution to this is x equals 0. When the argument is like x over 2, you don't have to worry too much about going around the circle a bunch of times. But when the argument is 2x, then you do have to worry. So if we look at this one, and I'll let you guys solve it, I think. But when you look at this one, make sure you get all solutions. Because the 2x, when you solve for it, it's going to end up only giving you half the solutions. So for this one, you have to go around twice. Let me see. I'll show you what that looks like. Cosine 2x minus 2 cotangent 2x equals 0. I want to factor out, actually, let me go ahead and write cotangent as cosine over sine. And then you can see that you can factor out the cosine of 2x. And 1 over sine 2x, I'm just going to leave it 1 over sine 2x so that we don't go to cosecant and then have to go back. Okay, so then this is going to have 2. Cosine 2x can be 0, and 1 minus 2 over sine 2x can be 0. I'll leave this one for you to finish. And for this one, I'll show you what I'm talking about, going around the circle twice. So cosine of cosine of an angle is 0. That happens in 2 places. Cosine is 0 here and cosine is 0 here because you're not moving in the x direction. And this is pi over 2, and this is 3 pi over 2. So when we set our argument 2x equal to pi over 2 and 2x equal to 3 pi over 2, and we solve for x, here we're going to divide both sides by 2, so x is pi over 4. And here x is 3 pi over 4. Oops. And if I add 2 pi to this, let's see, I get x equals, is that 5/4 pi? Actually, I'm just kidding. Okay, so let me cross that out because I really didn't want to add 2 pi. I really wanted to add pi. So that's the problem. Okay, so let me go back, and I'm going back from here. I want to add to 2 pi at this step because my original, okay, so what I'm dealing with originally, I want to add 2 pi so that we go around twice and land on, we go around once and then stop here. And let me show you what that does. So we're actually adding 2 pi at this step. Then when we divide everything by 2, we get pi over 4 plus pi, which is 5 pi over 4. Whoops. Which is 5 pi over 4. This one would have been, let's see, 4/4, 8/4, that would have been 9/4, right? Adding 2 pi to pi over 4 would be 1/4 more than 8/4 because all the way around is 2 pi is 8/4. Excuse me. Okay, and so we want to make sure we get both of these because 5/4 pi is actually within the 0 to 2 pi restriction on our answer. So similarly for this one, you have the possibility for the answer that you get, or no, you're going to also want to finish up this one by adding pi to it essentially, and then for this one you want to make sure that you take that extra step. For the modeling, in all honesty, this is a terrible problem. I got it from your textbook, and what I don't like about it is there are just a lot of ways we could set this up, and so it makes it a little bit difficult to kind of compare answers and see what's going on. But you should be able to model with a sine function. Again, we're just briefly going through this. You won't see this a lot in calculus, but I do want to make sure that we review this so that you can see. Number 2 is a much better problem. Just pick it apart, figure out what the phase shift is, what the amplitude is, and you should be able to come up with the equation that describes the star's radius as a function of time, and I'll leave that to you guys. Okay, thank you, and I will see you next week.